Future Makers.
Let's make gravity mazes. With this FutureMakers Spark, your learners will explore gravity, create ramps and pathways for a ball to roll and change direction, and stay on track from start to finish, but design it from the finish to the start. On Earth, gravity pulls objects down, but in the universe, gravity is a force that attracts small things to massive things. For example, the moon is in the gravitational pull of the Earth. The farther away things are from something's center of mass, the less influence that pull has. That's why, as we move farther away from the center of the Earth, we become less and less pulled down by the force of Earth's gravity. After making gravity mazes, learners should be able to identify the difference between gravity and magnetism. Gravity is an attractive force between all objects with mass. Magnetism is an attractive force between something magnetized and materials attracted to magnets. Here's what each learner receives to make a gravity maze: 2 maze boards, 2 different sheets of die-cut foam parts, a triangle kickstand, a ball, a visual guide, and a reusable reclosable bag. First, have your learners take one board, remove all the dots, and recycle them. Next, prepare the foam parts. Remove all the shapes from both sheets. Store them in the bag once they're taken apart, and dispose of any foam scraps. Each maze part has a special function. Let's give them names. Ramps are long, straight pieces that your ball will roll on. Stoppers are shorter pieces that connect things together or plug in spots where a ball needs to bounce off. Extenders are extremely important. They lift ramps off the board, giving the ball extended surface to travel on. The hoop is the end of the maze. To make the board stand, you'll use the triangle kickstand. Insert some stoppers through 2 holes. It's important to know that where you put your kickstand might affect how the board balances and even where you can place foam parts later. Learners can choose either the long way or the short way, depending on how they want their board to stand. Once your board is standing, it's time to engineer a pathway that changes direction 3 times: zig, zag, and zoom, for the ball to reach the finish. We'll engineer this pathway backwards, from the finish to the start. Start by choosing where to attach the hoop. Take a ramp and weave it into the board so the end is close to the hoop, but not touching. The beginning of the ramp should be elevated 1 row of dots. A slight angle makes it easier for the ball to roll than a very steep angle. Mazes have no one specific successful solution. Learners can enjoy tinkering and experimenting to find their own solution. Building in reverse and testing as you go is the only way to keep your ball on track. It's normal for the ball to go off track right away. You can use stoppers to keep the ball from rolling off. As they build, they'll apply the engineering design process, testing and validating the placement and position of their parts. Continue adding ramps until the ball can zig, zag, and zoom without falling off. 3 changes of direction are a great test of a learner's engineering design skills. Sometimes learners may find their ball rolls off, jumps over, or falls through parts that they've made. That's where stoppers and extenders come in handy. Extenders lift the ramp off the board, keeping a ball rolling instead of falling. There's strips of extenders connected together like fingers that work great for this. Stoppers can be plugged into the board and extenders to direct the ball. Add a stopper to the hoop to keep the ball from jumping out. It's going to take several tries and is normal for learners to assemble and disassemble parts. Encourage them to stick with it and keep testing. Small changes in the angle of the board affect the way the ball rolls. Encourage learners to do this and not touch the board. Making the ball roll hands-free is the best test. Have a peer test their maze so they can observe the ball rolling without feeling the urgency to fix it right away. Each learner receives 2 maze boards. For those looking for more of a challenge, they can grow their maze, either sideways or vertically, to extend the path for the ball to follow. A great extension is a collaborative challenge. One learner's maze can be connected to another's, where the end of one becomes the beginning of the other's. They'll need to collaborate and plan how 2 mazes can become one. Once both learners have their boards connected, they can try connecting with other learners to make a giant multi-board maze. This may require using the wall to prop up their creation. Mazes are designed to be taken apart and go home with learners to keep. Plan on deconstructing the project before it leaves for further learning at home. Congratulations on creating gravity mazes. Every spark your learners make is unique and theirs to keep. They'll remember the projects they make with you for years to come. Thanks for watching.
FutureMakers.